Hello there, welcome to the 31st and last video in the Learning Everything We Can Learn from VisionOS Documentation. As you can see here in this list, we have gone from the first item, creating your first VisionOS app, to the last one, making your existing app compatible with VisionOS. If there are future documentation, we will add that to this series. But with that, we have come to the last article in Learning Everything We Can Learn from VisionOS Documentation. Let's modify your iPad OS or iOS app to run successfully in VisionOS. A compatible iPad OS or iOS app links against the iOS SDK and runs in VisionOS. Although VisionOS provides a complete set of iOS frameworks for linking, some features of those frameworks might not be available due to hardware or usage differences. To ensure your app runs correctly in VisionOS, handle any missing feature gracefully and provide workarounds whenever possible. Perform availability and authorization checks before using features. Some frameworks offer APIs to let you determine when framework features are available or whether your app is authorized to use them. Always check these APIs before you try to use the corresponding features. And don't assume a feature is available because the necessary hardware is present. The device's configurations also play a role in determining the results of some availability and authorization checks. And features might not be present when your app runs in Simulator. If any availability or authorization checks fail, don't try to use associated feature in your app. The following frameworks support availability or authorization checks. First, Activity Kit. Check the R activities enabled property of activity authorization info to determine if live activities are authorized. ARKit. Check the is supported property of your configuration object to determine availability of augmented reality features. In VisionOS, ARKit views such as ARView are never available. So isolate interface code containing those views to the iOS version of your app. AV Foundation. Identify which cameras are available using the AV Capture Device Discovery Session class. Don't assume the presence of specific cameras. Automatically assessment configuration. Check for error values when you configure an AE assessment session object. Contacts. Use the CN Contact Store class to determine your app's authorization status. Core Bluetooth. Use the Core Bluetooth Central Manager and Core Bluetooth Peripheral Manager class to determine features available and your app's authorization status. Core Haptics. Call the capabilities for hardware method of the haptic engine to determine the available features. Core Location. Check the property of CL Location Manager to determine the availability of location services. Core Motion. When the property of CM Motion Manager to determine the availability of accelerometers, gyroscopes, magnetometers, and other hardware sensors. Core NFC. Check the reading available property of your reader session to determine if NFC tag reading is available. Event Kit. Use the EK Event Store class to determine your app's authorization status. Exposure Notification. Use the EN Manager class to determine your app's authorization status. Health Kit. Use the HK Health Store class to determine if health-related data is available. HomeKit. Check the properties of HM Home Manager to determine your app's authorization status. Local Authentication. Use the LA Context class to determine the authentication policies you can use. Media Player. Use the MP Media Library class to determine your app's authorization status. Nearby interactions. Check the device's capabilities, properties of your session to determine whether features are available. Photo kit. Use the PH photo library class to determine your app's authorization status. Proximity reader. Check the is supported property of the class reader object to determine if tap to pay on iPhone is available. Replay kit. Check the is available property of the RP screen recorder to determine if screen recording support is available. Room plan. Check the is supported property of the room capture session object to determine if LiDAR scanning is available on the device. Sensor kit. Use the SR sensor reader class to determine your app's authorization status. Speech. Use the SF speech recognizer class to determine if speech recognition is available. User notifications. Use the get notification settings completion handler method of the UN user notification center to determine your app's authorization status. Watch connectivity. Call the is supported method of the watch WC session object to determine if the framework is available. Handle environmental differences appropriately. Apple Frameworks takes a device agnostic approach whenever possible to minimize issues when you use them on different device types. Apple devices come in a variety of shapes and sizes and with different sets of features. Rather than build your app for a specific device, make sure it adapts to any device and can gracefully handle differences. Build robustness into your app during the design process. Avoid assumptions that might cause your app to break when it runs on a new device. And make sure your app adapts dynamically to different conditions. For example, don't assume the device type or idiom is always iPhone, iPad, or iTouch. Avoid decisions based on the current idiom. If you do rely on the current idiom, provide reasonable defaults for unknown idioms. Design your app to handle unexpected hardware or features. Specific hardware and features might not be available for many different reasons. For example, a feature might not be available when your app runs in simulator. Perform availability checks whenever possible and handle missing features gracefully. Design your windows and views to adapt dynamically. Build your interface to adapt dynamically to any size using SwiftUI or auto layout. Assume the size of your app can change dynamically. Don't assume the device has a specific number of displays. People can connect iPad and iPhones to an external display, and VisionOS devices can use two displays to create a stereoscopic version of your app's content. Don't make assumptions based on the available frameworks or symbols. The presence or absence of framework or code symbols is an unreliable way to identify a device type and can change in later software updates. Don't assume your app runs in the background. VisionOS doesn't support the location, external accessories, or Bluetooth peripheral background execution modes. Don't assume the background apps are hidden. In VisionOS, the windows of background apps remain visible, but are dimmed when no one is looking at them. The only time app windows disappear is when one app presents an immersive space. When you make decisions using device details, your app might produce inconsistencies or erroneous results on an unknown device type, or it might fail altogether. Find solutions that rely on environmental information rather than the device type. For example, SwiftUI and UIKit start laying out using the app's window size, which isn't necessarily the same as the device display. Device-specific information is available when you absolutely need it, but validate the information you receive and provide reasonable default behaviors for unexpected values. Audit your interface code. To minimize disruptions, VisionOS runs your compatible iPad or iPhone app in an environment that matches an iPad as much as possible. Windows and views retain the same appearance that they have in iPadOS or iOS, and the system size your app windows to fit an iPad whenever possible. When building your app interface, make choices that ensure your app runs well in VisionOS 2. Adopt the following best practices for your interface related code. Support iPad and iPhone in the same app. Create one app that supports both devices. rather than separate apps for each device. SwiftUI and UIKit support adaptable interface, and Xcode provides tools to help you visualize your interface in different supported sizes. Organize your interface using scenes. Scenes are a fundamental tool for managing your app's interface. Use the scene type in SwiftUI and UIKit to assemble and manage the views you display in Windows. Adapt your interface to any size. Design your interface to adapt naturally to different sizes. For any introduction to SwiftUI views and layouts, see Declaring a Custom View. For information about laying out views in UIKit, see View Layouts. Don't access screen details. VisionOS provides reasonable values for UI screen objects, but don't use those values to make decisions. Specify the supported interface orientation. Add the UI supported interface orientations key to your app's info plist to specify the interface orientation it supports. Supports all interface orientations whenever possible. VisionOS adds an interface rotation for your app buttons only when the key is present. Update hover effects in custom views. Hover effects convey the focused view or control in your interface. Standard system views apply hover effects as needed. For custom views and controls, verify that the hover effect look appropriate in VisionOS. Add or update the content shape for your hover effect if needed. Adopt vector-based images whenever possible. Vector-based image scales well to different sizes while retaining a crisp appearance. If you use bitmap-based assets, make them the exact same size you need. Don't use oversized assets, which require extra work to display at the correct size. If you want VisionOS to display your app's interface in a particular orientation at launch, add the UI preferred default interface orientation key to your app's info plist. Set the value of the key to one of the values in your app UI supported interface orientation key. For example, if to specify a preference for a portrait orientation, set the value of the UI interface orientation profile, portrait. Add iPad and iPhone to the key names to specific device-specific orientation preferences. Respond gracefully to missing features. If your app relies on frameworks that behave differently in VisionOS, update your code to handle those differently. Availability check gives you a clear indication when you can't use a feature, but some frameworks might have more subtle behavior. Throughout your code, make sure you respond to unusual situations. Handle error conditions. If a feature function throws an exception or returns an error, handle the error. Use error information to adjust your app's behavior and provide an explanation of why it can't perform certain operations. Handle nil or empty values gracefully. Validate objects and return values before you try to use them. Update your interface. Provide appropriate messaging in your interface when a feature is missing, or remove feature-specific views entirely if you can do so cleanly. Don't leave empty views where the feature was. For example, about frameworks that behave differently in VisionOS, see checking whether your existing app is compatible with VisionOS. Remove code that's using deprecated APIs. If your app currently uses deprecated APIs or frameworks, update your code to use appropriate replacements. Deprecated symbols represent outdated features, and in some cases might not do anything when you call them. To prevent potential issues, replace them with a modern equivalent to ensure your code behaves as expected. The following frameworks are deprecated in their entirety in iPadOS, iOS, and VisionOS. If your app still uses these frameworks, move off of them immediately. The reference documentation for each framework includes information about how to update your code. Accounts, address books UI, assets library, iAdd, newsstand kit, notification center, and OpenGLES. And with that, that is the last article in Learning Everything We Can Learn from VisionOS Documentation made by Apple. And also the last article we are going to do for this series. And now we're going to move on to creating sample apps as the Vision Pro becomes available to us.